Okay, everyone, so today we are going to be talking about dilutions. And here is our formula, M1V1 equals M2V2. So let's talk about what these variables are. So let's see, let me grab my pen, and here we go. Okay, so M stands for molarity. And V stands for volume. Perfect. So let's think about these two things separately. First, let's talk about molarity. Molarity's formula is moles over liters. Okay? And then volume, we can measure volume in liters, like how you would a soda. You go to the gas station or the grocery store and you buy a 2 liter of soda. So that's one. And then we have milliliters. Sometimes you might see centimeters cubed. Don't let this freak you out. This is just a unit. It doesn't mean we have to do any fancy math or anything crazy like that. It's just a unit. Alrighty, perfect. So we have molarity of the first thing times molarity of the first thing times the volume of the first thing equals molarity of the second thing times the volume of the second thing. So when we see the number 1 next to M and V, that means first. What came first? Wow, I spelled first wrong. There we go. And then 2 means what happened last. All right, so let's try an example together. It says, if 80 milliliters of an 8 molar solution was diluted to a 1 liter container, what would the new molarity be? My recommendation is that we go ahead and write out all of our variables. So we have M1 and V1, and we have M2 and V2. Put my little equal signs. All right, so if 80 milliliters, what is milliliters? Is that molarity or would that be volume? I would say that this is a volume of an 8 molar solution. So we know these two things are connected together. We have something that has a volume of 80 milliliters and a molarity or a concentration of 8. So M1 is 8, V1 is 80 mils. All right. And it was diluted, meaning we added something to it to make it not as strong, to a 1 liter container. What would the new molarity be? New is the same thing as last, which is the same thing as 2. So we're looking for our new molarity, our second molarity. So that would be the X. We don't know. And then our second volume is 1 liter. Okay, but we have a small problem. Let's see. This is measured in milliliters, and this one is measured in liters. We have to make them equal the same thing. So our conversion factor is 1 liter equals 1,000 milliliters. So I'm going to change this number to 1,000 milliliters. And you could have changed this one. This one was just easier. You could have changed the V1, but you did not have to. Okay, so our volumes now match. Good. Let's go ahead and plug it into the formula. So M1, here's our formula again. M1 V1 equals M2 V2. M1 is 8. V1 is 80. Equals M2 is our X. And V2 is 1,000. So now we have to solve for our variable X. Now, we could do this a couple different ways. We could solve the math on the left side of the problem, or we can just move over that 1,000. So I'm going to solve this 8 times 80 first. 8 times 80 equals, that is 640. And we didn't do anything to the right side yet, so that's just 1,000x. Now to get x alone, I'm going to divide both sides by 1,000. So now, I'm going to carry this over here. X equals 0.64 molar is our final answer. Alrighty. All right, let's do one more problem together. It says if a 10 molar solution was diluted to a 0.5 molar solution that had a volume of 400 mils, how many milliliters of the original solution had to be added? All right, so we have these variables, same as we had a moment ago. M1, V1 equals M2, V2. So M2 and V2. Okay. So it says if a 10 molar solution was diluted to 0.5. So originally it was 10, and then it diluted to 0.5. So M1 is 10, and M2 is 0.5. So it was 10 diluted to 0.5 that had a volume of 400 milliliters. How many mils of the original solution had to have been added? So when we diluted it to 0.5, it then had a volume of 400. So this V2 is 400. And how many of the original? Original is the same thing as started with, which is the same thing as the number 1. So V1 is our X. Same formula, M1 V1 equals M2 V2. Fix my equal sign. All right. Now let's plug all these things in here. So M1 is 10, V1 is X, M2 is 0.5, and V2 is 400. Alrighty, so we can solve this problem by simplifying or multiplying the right side together. So 0.5 times 400 is 200. And we can clean up this side by just saying 10x. Now we still have to get x alone, so I'm going to divide both sides by 10. These 10s go away, so x equals 20 milliliters. And that is your final answer. Okay, let's do a problem that's a little bit more of a challenge. So it says that if you add 0.75 liters of a stock solution to make 2.25 liters of a 1.25 molar solution, what was the concentration of the original? Okay, so it says if we add 0.75 liters of a stock solution. So first, a stock solution is like a pre-made solution that chemistry companies will send to chemistry labs. So this is just a pre-made solution. Good. And then we made, remember this word made? This means what you ended with. We made 2.25 liters of a 1.25 molar. What was the original concentration? Original means that's what we started with, which is saying the same thing as the number 1, and end is the same thing as saying number 2. Okay, let's list the variables. So we got M1 and we got V1, and then we can say M2 and V2. Okay, so we made So we ended with something that was 2.25 with a 1.25 molarity. Good. And what was the original concentration? So molarity is the same thing as concentration. Molarity is the measurement of concentration. So we don't know the original concentration, and we're still missing volume. So let's see. We added 0.75 liters of stock solution to make 2.25. So what did we start with? This is our end, 2.25, and this is what we added, 0.75. So get out your handy dandy calculator. We got 2.25 minus 0.75 equals 1.5. 1.5 liters is what we began with. Whew, okay. Now we can plug everything into the beautiful dilution formula. M2V2. Sweet. We got X. V1 we agree is 1.5. M2 is 1.25. V2 is 2.25. All right, so we can solve this right side of the equation by multiplying 1.25 times 2.25. And that will get us 2.8125. And now let's clean up the left. So we got 1.5x. Now we need to get x alone still, so we are going to divide both sides by 1.5. And x shall equal, let's figure it out. We're going to divide that 2.8 by 1.5. And your final answer will be 1.875. And that is molarity. Alrighty, hope this was helpful, you guys.